hope you guys are doing well. What I've created for you guys is a flow chart. You guys can print this off or save it somehow to help you guys when we do have a test over chapter 8. And this is just going to help you decide which test to use. This also should help you do your stats Olympics. So I hopefully you guys are having fun with that. And I hope you guys have a great day. And I hope this video helps you guys out. All right, so here's a flow chart I created. It maybe looks a little confusing, but when you do this, you want to start right up here with this question. Here are all the tests that we've learned how to run on our calculators. So let's just go through how you would use this flow chart. I'm just going to go over some questions we had on our Chapter 8 Google Slides. So this first question, in a random sample of LBHS students, 12 out of 30 girls and 17 out of 25 boys were going on vacation. Well, that's now 0 out of 56, but so that's how that goes. So what does that look like? Means or proportions? So definitely they're proportions. And then are we comparing one sample to a hypothesis or two samples to each other? Well, we have two samples, boys sample and girls sample, so we're comparing those to each other. So really all you have to do in your calculator is just find that test. So stat test and scroll down to where it says two proportion z-test. And basically you would just type in your two fractions, 12 out of 30, and see how those are each in their own category, and 17 out of 25. And it just said different, so I would just keep it not equals and calculate. And there you go. That one's pretty easy. All right, let's look at the second one. So Mrs. Todd's interested how much her students have learned in Chapter 9. She's going to compare her students pre-test and post-test. This is probably the most missed question. So let's go through. If we're talking about test scores, I should have probably made that more clear, but we're talking about averages, not proportions. So think of all the students' test scores, a pre-test and a post-test. So are we talking about means or proportions? Means. Are we talking about a single mean or two? Well, we're talking about two means because I want to compare your pre-test to post-test. Are these dependent or independent? Dependent means the samples depend on each other. Independent is like you have two totally different samples. Like you're comparing a football team to a basketball team. Here we're comparing the same kids to each other. So what we'd want to do is a match pair t-test. And I can review with you how to do that. There's no data right now to put in my calculator. So I just lost my page. Okay, so number 3, Bernie Sanders won 51% of the Democratic primary in Michigan. So that's an actual number. 51% is what really did happen. That's not a sample. But on a poll prior to that, 35% of the sample of 2,500 voters supported Sanders is significantly different. So what we have here is one sample, 35% of 2,500. And we're going to compare that to 51%. So when we get here, we're talking about proportions, and really this is an example of a one proportion. We're comparing our proportion to what we thought it would be. So if we go into stat test, one proportion z-test, okay, the null hypothesis is we would have expected 51% to vote for him. Sorry, I need to make that 0.51. Our x value is whatever 35% of 2,500 is. So I'm going to have this do the work for me. That has to be a whole number. 875 is a whole number out of 2,500. So you can't put a percent in there. You have to think of how many people that was. And we are wondering if this is a significant difference. So we would just calculate that. Okay. The NFL. High school coaches were discussing NFL defensive line or offensive line, whether they weigh more. Obviously, here we have a random sample of defense and a random sample of offense. And it says they were not able to find the true population standard deviation. So we're talking about weights of players. So that's not a proportion. That would be a mean. So we're talking about means. We're talking about two means. Are they dependent or independent? They're independent. We're comparing two totally different groups of players, offensive line and defensive line. This is not given, so we would use a two-sample t-test, and we would just type everything in our calculator. All right, let's look at the next one. The IQ test is normally distributed. That means we know the mean and we know the true standard deviation. A random sample of only 20 students took the IQ test, and these 20 students had a sample mean of 105. Is this significantly higher than the population average? So we're talking about means. Definitely talking about means. A single mean or two means. A single mean. we are given the true standard deviation is 15, so we would just use a basic t-test. We actually have enough information here to do this test. So we would input data. So our null hypothesis is, oh, sorry, I wasn't even showing my calculator. Sorry. So right here, the null hypothesis is not going to be 0. The null hypothesis is 100 because, see, that's the true average is 100. And the true standard deviation is 15. Sorry, we are not in a list, so I'm going to change this to stats. And our sample mean, see how it says X bar is 105, and I tell you that it's 20 students. And we want to know if they are higher than that true average. So make sure you select, we want to know if they're greater than the 100. And we just do calculate, and there would be our answer. We would fail to reject the null. Okay, and then finally, 20 students were asked to count how many times they could jump rope in a minute. Do you think the average student can jump significantly more than 50 jumps? I don't have enough information about my calculator, but this question is basically only 20 kids and wondering if they can jump more than 50 jumps. So we're talking about means, one mean. We're not given the true standard deviation, so we'd use a t-test. But we would have to have information to put in our calculator. I mean, I didn't give you enough information there, but we definitely could use a t-test. So hopefully that helps you guys out a little bit, and hope you're doing well.